So without further ado, I'd like to introduce our speakers today. So featured in the video I'm about to show is Dr. Emily Heaton with Iowa State University Agronomy, as well as the University of Illinois. And we've also got a couple great farmers using Miscanthus that are going to share their insights into this crop. That's Steve Schomberg from Muscatine County, Iowa, and Eric Runn, who's farming in Champaign County, Illinois. So again, feel free to submit your questions at any time, and we'll get started with the video.
Hi, my name is Emily Heaton. I'm a professor in agronomy at Iowa State University, and welcome to the Miscanthus field. Miscanthus? What's Miscanthus, you say? It's Miscanthus giganteus. And why would we be growing this in Iowa? Because this crop requires planting only once every 20 or 30 years, makes a crop like this or bigger every fall to harvest, and really only needs nitrogen every few years or maybe not at all for some of our research. So let me tell you more. Okay, so we planted this field of Miscanthus that you see behind me last spring, and Miscanthus is most susceptible to winter kill in its first year after planting. This is really the most tender time in the 20-year lifespan of this crop. So one of the ways we assess whether we have a good stand is we come out in the spring and we measure how many stems we have, just like you'd walk down a row of corn or soybeans and see and count your plant population. The way we do that is with what's called a frequency grid. This is just a piece of concrete reinforcing mesh that is cut into a 5x5 grid. And I'm going to put it down on the ground and count how many squares have a shoot of Miscanthus in them. And then I'll flip it and I'll count how many squares again. I'll do that 4 times. At the end, I'll have counted how many shoots of Miscanthus are in 100 squares. And that will give me a percentage of stems over a known area of ground. And that's the universal metric for considering successful stand development. So I just get down and I count which of these squares have a green shoot of Miscanthus in them. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. You want to look for where the base of the shoot is. So there is 9 grids filled, and then after you count it once, you flip it on edge and do it again. So now I'm in between plants, so I'll have fewer plants on the grid. That's fine. We want to get a spatial average of our field. So now I only see 2 shoots in this. So we had 9 in the last one, now we got 2, we're up to 11. Four. So 17 plus 4 is 21. So we had 21 out of 100 grid squares filled for a 21% frequency of occurrence. And we will keep measuring this over the next few weeks as new stems are emerging, but for the first week of May, that's a very good frequency of occurrence. Time I saw you, they had just emerged and we were just starting to talk about how we count plant populations in a crop like Miscanthus. Since we've talked to you, we had a really hard frost event. In fact, last week this field was completely brown. It was a sad day. But now we're back and I'm going to show you again how to measure plant populations and talk to you about how Miscanthus grows out of frost damage. Randomly through our frequency grid, which is just a piece of concrete reinforcing wire that's got a grid of a known area, randomly threw it in the field, and we're going to do a few flips and count how many holes have a Miscanthus stem in the base of it. So when I say that, I'm going to count where the base of the Miscanthus stem is, not where the top of the shoot is. Just a detail, but it comes in handy when you get confused when you're trying to do it yourself. So this one is just barely in my opinion. So I got 1, 2, 3, 4, 5, 6 squares that have a Miscanthus stem in the grid. So that's a 6. Now we'll give it a flip. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. Got a flip of 14. So 14 plus 6, we're at 20. One more flip. All right, so this is our third of 4 flips, and you'll notice there's only one shoot in the grid this time. So we got a flip of 6 plus 14 is 20. Now we're at 21. And you might be thinking, oh, this looks bad, but this is just a normal inter-row space. So it's fine that there's no plants here yet. The crop will fill in over time. And now we flip one more time for our last of the 4 flips in this location. And count one more time. 1, 2, 3, 4, 5. I'm only counting green shoots, by the way. So this one has last year's stems, but none of this year's stems, so I'm not counting it. 6, 7, 8, 9. So that takes us up to a total of 6 plus 14 plus 1 plus 9, 31, 30 stems, is that right? 21, yeah, 30 stems. 30 stems in our total flip, which 30 of these squares had a stem in it when we flipped. So that's a frequency of occurrence of 30%. So Jackie reminded me that last time we were out in this field 3 weeks ago and we flipped frequency grids in this area, we had a frequency of 21%. So this one I just did, we had a frequency of 30%. So it seems like we have more shoots up this time than we did 3 weeks ago, which makes good sense. Of course, to get a good spatial estimate of establishment in your field, you're going to want to do frequency measurements in more than one place. Just like if you're trying to figure out your plant populations in a corn or soybean field, you go out and you sample plant populations over a few different acres. So we'll do that here. We'll get a spatial average of this field and we'll let you know what we find. All right, so we just finished doing frequency of occurrence in another spot in the field, just finished 4 flips and came up with 34 out of 100 of these individual grids, squares, had a plant stem present in it, so that's a frequency of occurrence of 34%. And I just wanted to point out a couple of things. We're getting a spatial average over the field, of course, when we do this by flipping it multiple times. But if you can notice, some of these stems are just hard to see. This is a newly emerged shoot, and they come up red, similar to like a peony shoot. And they don't put out the green leaves. The leaves are still down here in the base of the stem, where the meristem is, just like corn comes out of the ground. And the green leaves will start pushing up through the shoot. So you can see over here, there's the red sheath covering, and now the green leaf is pushing up through that sheath. So here, when we came out last week, this shoot was just nicely out of the ground, and all this leaf right here got frozen. So all this was frozen last week, and it looked terrible when I came out last week. But we've had a few warm days and some rain since then, and the meristem in this shoot has been pushing out new leaves, and this is pushing that frost damaged leaf right out of the way. The shoot itself is alive and well. So let's dig down and find out how that works. So what I'm showing you here is that Miscanthus shoots grow from a rhizome network. So hopefully you can see that this is a big, thick stem underground. And I don't want to tear up this plant too much, but we'll see if we can just get this stem out to look at. Pretty woody. All right, so I broke that off down in there, but the rhizome is, oh, look at all the worms. Still alive and well in here. So what I've done here is I've pulled out the stem and the rhizome to which that stem was attached underground. So I broke off the stem. It's quite small here, but I hope you can see there are new buds along this rhizome. A rhizome is just an underground stem, and just like a branch on a tree has many buds, a branch on the rhizome has many buds. So even if I broke this stem off, these would then start growing, just like taking the top out of a tree allows the next branch down to start growing. So this is how Miscanthus reproduces. And when we planted this field, we planted it from rhizome pieces similar to this. Welcome back. It's September now. So a few things have changed since the last time.
Sorry about that. We'll get right back into sharing the video.
Show you while we're here though is how Miscanthus compares to biomass sorghum behind me here. So sorghum is an annual crop and it's incredibly productive for just one single growing season. But the sorghum won't stand in the field very well for us over the winter. So we'll harvest this in the next couple weeks before we get a killing frost, because once that killing frost happens, sorghum starts to lodge pretty dramatically pretty quickly. So that means even though it has so much biomass in a single year, this is very productive compared to even to our corn crops, it's not quite as economically or environmentally efficient as a perennial crop, because you still have to come back and plant it in the field each year. So that has added cost of seed and fertilizer and equipment, but of course then also just extra greenhouse gases with tillage and trips through the field. Now let's get a little bit closer to that Miscanthus. Okay, so one thing to notice here inside the Miscanthus stand, we're right at the edge of the field, is that it's darker than outside the stand. I mean, that's common sense, but it becomes important as you look into the stand. So hopefully you can notice it right here by the edge of the stand. There's a couple little weeds trying to survive, but if you look further into the stand, the weeds are gone. And we don't put herbicide on this crop after the first 2 years of growth because we don't need to. The Miscanthus grows so fast that it shades out those weeds. Hopefully you can also see the beginning of a litter layer developing in this 2-year-old stand. There's starting to be a leaf drop, and this will accumulate over time, so much so that in fact sometimes we harvest just the leaf litter and it's used for erosion control devices. But this also helps protect the soil from wind and water erosion, and it also buffers it from changes in temperature and changes in moisture. So this year, 2020, we've had a very dry season, and we've just had 3 inches of rain at this field site in the last week. And hopefully you can see right here, there's still cracks in the ground that are there even after that 3-inch rain. The Miscanthus growth hasn't seemed too stunted. We've got firing of lower leaves, but it is September 14th, so that's just natural senescence. It's not, I don't think, drought related. And we can now get the shovel out and see what the roots and rhizomes look like and see if we see any evidence of drought damage below ground. So I've dug up a few stems here. And first of all, I want you to notice that the soil sticks to the below ground system. And I'm saying below ground system because it's made up of both roots and rhizomes. Let me show you what I'm talking about. All right, so here we have roots. And these are fairly big roots. Some of them are almost 1/4 inch in diameter. And these are the roots right near the surface. There's some even bigger ones that go all the way down. I've broken off some of these bigger ones as I dug it up. But those deep roots can go quite far and are the ones that serve, in some ways, like a taproot.
Iowa Learning Farm.
Other types of plants to access deep reserves of moisture. All right, so now I'm going to show you with the rhizomes. Remember when I showed you this at emergence, and they were much smaller. Now look how big these things have gotten. This one's 4 inches long by, gosh, an inch wide. Some of them are even bigger. We just pull this apart. I want you to notice how the soil sticks between those rhizomes. They're all quite firm. So if I expected to see drought damage in this crop, I would look for dead roots and dead rhizomes where the plant had quit sending them reserves as they were having trouble, as the plant was having trouble growing from drought. Wow, that's the snap you want to hear from a healthy rhizome. So this is white, completely healthy, full of moisture, and in fact, yeah, an actively developing rhizome with multiple lateral buds. So these will all be new stems next year if conditions allow. So sometimes the canopy is so full that these new buds won't all grow because, like the weeds, they get shaded out too. So those are some of the things we're still working on in Miscanthus, is how to get every stem to grow and increase yield. All right, one more thing I wanted to show you relates to how Miscanthus cycles nutrients. So it's September 14th, we just had a few cool nights in the 40s, and the leaves on the trees are starting to think about turning colors. Same with the leaves on the Miscanthus. These are some of the lower leaves, but as soon as we get a bit of a frost, we'll see the same thing on the whole canopy. What I hope you can notice here is that there's some green and there's some yellow. This is just natural senescence of the leaf. And as that crop's turning yellow, the nitrogen that was in this leaf that made it green because it was in chlorophyll and photosynthetic enzymes, that nitrogen is getting recycled back down this plant stem to these rhizomes. So the entire plant acts kind of like just a big recycling unit. It stores the nitrogen down here all winter, and not just nitrogen, by the way, same with its sugars. It stores them in these rhizomes all winter, and then when spring comes and the soil temperatures start to get to 55, 60 degrees Fahrenheit, the new shoots come up, the nitrogen gets sent right back up the stem, allowing the plant to grow leaves and the stem very rapidly. And that's how the plant outcompetes weeds, because this internal nitrogen cycling allows the plant to grow so quickly in the winter, or in the spring. And of course, because the plant recycles its nitrogen, or at least most of it, there's not much taken off the field when we harvest. That's part of the reason why we wait till winter to harvest this crop, so that we don't have to really apply much inorganic nitrogen fertilizer to the crop, making it very efficient and cost effective. All right, so let's step back for a minute and think about where Miscanthus might make sense in an Iowa agro-ecosystem, or an Iowa farm economy, or the Midwest for that matter. From our work so far, it seems that there's no chance in the near future that Miscanthus is going to replace corn and soybeans, nor should it. There is nothing we can eat in this crop. But it is really useful for a lot of other things. The bedding market in particular is really taking off, not just in Iowa, but also up and down the eastern seaboard, especially in large poultry packing houses. The conservation bedding markets are really taking off. So there are markets that are developing in addition to the ones that we study here at the Sabre Farm, which are mainly related to bioenergy. But where might you think about Miscanthus in the landscape or on your farm? Well, the way I think about it right now is for those places that maybe aren't giving you the best performance in corn and soybeans. Maybe that means that they're not performing economically, or maybe it means they're not performing environmentally. Oftentimes the same place fails both economically and environmentally, right? Maybe some of those sandy spots you have, or a pothole bottom. Those are places where we're investigating growing Miscanthus to see if it can pay for itself in terms of dollars, as well as in terms of improved soil quality and improved water health, that sort of thing.
All right. Well, as Emily and Steve and Eric get their cameras and their microphones unmuted, again, you can submit your questions at any time via the chat, and we'll get to those here momentarily. But in the meantime, I'm going to turn things over to the crew pictured here to continue the discussion on Miscanthus today.
Thanks so much, Liz. This is Emily Heaton, and thanks for joining us today. We're really excited to have such a big group on the virtual field day here. So I just wanted to give some quick introductions to what's going to happen next. I have a couple slides to complement the video that you just saw. And then Steve Schomberg, pictured here in the middle, is going to tell you a little bit about his Miscanthus and overall farming operation, as is Eric Rund, and who's been doing this for slightly different markets than Steve has. So I've worked with Steve and Eric for several years now, and I find them to be incredible resources about Miscanthus. So please type your questions in the chat, and we'll just show you a couple quick slides about what we do and things we want to share with you. And then with the rest of the time, we'd like to have a panel discussion, and we're here as a resource for those of you out there with questions on Miscanthus. So I do want to say that today's field day is not a how-to on growing Miscanthus, but you can find a lot of that information in the Iowa State Extension store, which is linked at the bottom, and just search the word Miscanthus. Next slide, please, Liz. All right, so this figure just highlights some of the reasons why you might want to consider growing perennials in Iowa. Many of you might be familiar with the Prairie Strips work. My team works very closely with the Prairie Strips team in Iowa and outside the state now. And so there's a lot of different motivations that some people have for adopting perennials or incorporating perennials into their farming operation or their land management operation. However, profitability has to be part of it for everyone. No one can be sustainable or regenerative if they can't sustain or regenerate money. So that's going to be a common theme of our work and what you hear with Eric and Steve. Next. This is the way I've been thinking about Miscanthus most commonly of late. So this is a picture of me standing in the middle of a drowned out corn plot with Miscanthus behind me and what used to be soybeans underwater. And there's some sorghum and some CRP behind me. And so we have work funded through the Department of Energy and the USDA to try to understand how our prairie pothole landscape in the Midwest is adapted or not adapted to the crops that we're growing today. How can perennials help us financially and with our water quality issues that we have in the Midwest? So we have a rather large body of work in that area that we can follow up on at another time, or I can send you resources if you're interested. But this is the way we see Miscanthus as sort of an incorporation to protect our corn and soybean agroecosystem, because we're hemorrhaging soil and nutrients with the practices that are used today. Next slide. This is a figure taken from some colleagues that Eric and Steve and I work with at a company called Agrotech. You might be wondering how you get Miscanthus, how you plant Miscanthus. Agrotech is based in North Carolina, and it's North America's largest rhizome producer right now. So Miscanthus is a sterile crop. It's planted by rhizomes, such as are shown in the top right corner. Those rhizomes have to be dug and processed. That's what the top panels are. And then Agrotech has built a specialized planter that you see in the bottom left there. So right now it's fairly low input for the landowner or land manager who wants to adopt Miscanthus. You contract the planting, and oftentimes we contract the harvest. On the bottom right panel, I'm featuring some new technology from a company that we also work with in Canada called New Energy Farms. They've been spending a lot of their time focusing on sugarcane, which is another rhizomatous crop, and have developed a new technology to plant sugarcane rhizomes or stem pieces in a manner that looks a lot more like seeds. They even call it seeds, but with a C there. And so that's something that we see coming up in the future. if we were going to develop new varieties of Miscanthus or plant Miscanthus more widely, there is increasingly technology that would let us treat this challenging rhizomatous crop a little bit more like the seeded crops we're used to. Next slide. All right, I'm going to turn this over to Steve, and Steve will tell you a little bit about his history with Miscanthus and his operation. Steve?
Thank you, Emily. I'm not getting my picture. Are you hearing me? Ah, okay, good. I first was introduced to Miscanthus when I had an opportunity to tour the research farms at the University of Illinois, where Emily actually was working as a graduate student at the time, back in 2003, and was introduced to Miscanthus. Then as Dad failed in health and I began to play a bigger role in running the farm back in Iowa. And after he died a few years, I returned to Iowa with so that I could play a much more active role in managing and running the farm. We have about 1,000 acres of row crop split between soybeans and corn. We do a 2-crop rotation. And one of my intents when I joined the farming operation and started being the active manager was to look for a third cash crop. I got very nervous with the roller coaster ride with corn and soybeans, and was looking for a third crop that might work. And I had become very interested in perennials through some work being done on wheat products that I had learned about. So Miscanthus is a perennial, so it was a plant that was very interesting to me. And I, by chance, learned about the University of Iowa's interest in growers who would grow Miscanthus to under contract that they would then use as a biofuel. And so I jumped at the opportunity and was fortunate to be the first grower in Iowa to actually plant Miscanthus on a field. And for the first couple of years, I gradually expanded that contract with the University of Iowa, with my intent being I really wanted to be comfortable with learning how to grow Miscanthus and have confidence that I could grow it. And when I reached that point, I decided to create a commercial field that I would market and test out the profitability of it. So if I have the next slide. The fields that I selected to have us grow Miscanthus were fields that met that criteria, several of the criteria that Emily talked about. They were less productive. Yield monitors, when you hit those areas, would drop. They had more slope. The soil types were more erodible. They had odd shapes. They were frustrating to farm with the kind of equipment we're now using in terms of the size of equipment. And so I thought those were good sites to choose. You can kind of see from the picture that our farms lie at that boundary between the tall grass prairie and the timber lands. There we have remnants of old stand timber, and then just next to them we have the prairie soils that were the result of prairie. So we have a varied landscape, and so the idea was to choose those spots for Miscanthus that weren't very good for corn and soybeans. We now have 63 acres total. 15 of those are on the commercial side, and the others are under lease, under contract at the University of Iowa. Next slide. Emily mentioned productivity. That is one of my goals. As a farmer, and I own the farms with my sisters, we often talk that we want to be good stewards of the land, but we also have to turn a profit. And so the two things always have to be done in lockstep. First of all, the University of Iowa contracts in their rental agreements with the growers tend to be in the neighborhood of what you might get paid for CRP acres. It's not a one-to-one correspondence, and it varies a lot on soil productivity and size of field and how much difficult it would be to harvest and a number of factors. But the land lease rates were similar to CRP, which I was satisfied with. Then as a commercial crop, the first bullet really is markets. And I can't emphasize that enough. If you grow a crop, in order to get paid for it, you have to have some kind of a market. We're fortunate in working with AgriGrowTech in that they have worked in Iowa to find markets beyond the fuel market in erosion control products, bedding, and there is also a company now that that is in Tennessee, I believe, that has a replacement for plastic, styrofoam, and paper that takes a product out of Oklahoma, Miscanthus and switchgrass. But at some point, I believe that will be a product or a possibility for us also. I'm currently netting about $86 a ton, less the fixed expenses for certification. That's weed-free certification. Iowa has a weed-free certification process, and in the erosion control business, the person who we work with, the contractor, needs to certify to his clients that this product will not be invasive and will not spread weed seeds around. So we have to get that certification. And of course, there's the usual farm costs of insurance, taxes, utilities, and so forth. Nitrogen is a big question mark. Emily and her people are doing research on that with trials on what N is required. I have put very little nitrogen on. I think this next year I'm going to put on some urea, maybe 100 pounds an acre, because I'm seeing some signs in the commercial crop that maybe it needs some nitrogen. It just doesn't have a good color and hasn't grown quite as vigorous as in other years. And of course, you have to amortize the planting expense in some way, because what's different about a perennial crop is that you have the upfront costs. So you have to be able to invest in it. I don't know, maybe it's more like a cow-calf operation where you've got to have the cows. You can sell the calves, but you got to have the cows first. So you have some investment ahead of time and you eventually pay off that investment. I think about it as I just assign when we planted the Miscanthus, it was about $1,000 an acre. So I think of, $100 an acre a year over 10 years in terms of my economic models. Harvest too, the first year, there's really not that many stems that grow, and it grows only, at least in my experience, about 5 feet, something like that. By year 2, then you get up into the 7 or 8 feet height, and by year 3, it's 12 feet tall, and the number of stems increases very rapidly. And so that rhizome that's planted just continues to get larger and larger and larger. Emily, I thought I was amused in the video. She easily dug up those rhizomes. A rhizome that's 3 to 5 years old would take much more effort than she was putting into it in order to dig up. So as I run my numbers out, and of course it's extrapolating, but once I've paid my upfront costs and sort of after the 4th harvest year, and without putting land costs into it because that's so variable, I'm projecting to net about $500 per acre. Now, will that happen? We'll tune in a few years and ask me. But right now I'm optimistic that it's a plant that you're going to make money at. And my intent is to plant more acres in better soils as the market grows, but I'm not going to plant ahead of the market, if you will. I'm going to wait till the market's there before I plant more. Okay, thank you.
All right, and Eric has got a little bit different operation, so he's going to share some of his information as well. And I think he just froze.
About the time Emily was finishing her undergrad, I believe, at the University of Illinois. And I lived right down the road from where their energy farm was in operation. And so I was really intrigued by the idea that you could grow more biomass, which gave you more ethanol per acre than you could corn. So back then, ethanol was the hot thing, and corn was $4 bushel, and it really looked like the thing to be involved in. And gas was $4 a gallon or better. So the outlook for ethanol looked really bright. And I figured if we were going to grow ethanol, the best way to do it was to be using something other than corn. I got to know Steve Long, who I call the father of Miscanthus in Illinois anyway. And from him, he gave me 13 rhizomes after one field day. And that was my start. And I propagated those and grew more of them. And then by then I bought 5 acres worth of rhizomes from the same company that Emily was talking about that creates the seeds. They were growing rhizomes then, little plantlets you could plant. So I ended up planting 5 acres of rhizomes, and from those I ended up propagating that into about 33 acres of Miscanthus. And it wasn't all easy. I learned a lot, still learning all the time. One thing intrigues me about Miscanthus, it's a new crop. We're still learning about how to grow it, what it takes, what it needs. It's not like corn and beans where there's companies researching it constantly year round, year to year to year. Miscanthus, you have to learn and dig and do your own experiments and hunt and peck for little knowledge that's out there. But like Steve, if I was going to grow it, it was going to have to, I was going to have to have a market for it. It was going to have to pay for itself. And the crops I could grow against it were corn and soybeans. If I didn't plant Miscanthus, I planted those two. Even on the poorer ground that probably shouldn't have been planting row crops. So I planted my Miscanthus on that poor ground. It wasn't poor enough to be CRP, but it wasn't good enough to be row crop, I didn't think. So that's where I planted it. And comparing it to corn and soybeans then, if I grew corn and soybeans this year, what you're looking at here is a table of costs and incomes as of December 31st. And if you'll recall, on December 31st, corn was $4.75 a bushel, and beans were over 13, and Miscanthus was 85. I raised my price to 90 at the beginning of the year, so I used 90. So if you run those numbers through, 230 bushel corn, which was a little under what we had this year, my net per acre was $284. Soybeans was $332, and Miscanthus was $129. keep in mind though, if you farmers will realize, and I'm sure you do, we got a lot of money from the government this year. $90 an acre on corn and darn near 100 on soybeans. Market support as well as the regular ARC and PLC payments. Those aren't going to be there every year, but they were there December 31st. So that's what this is a snapshot of my farm operation right then. Next slide. Yeah. If you take those numbers and string them out over the times that I really started getting a Miscanthus crop about 2011, that's when I got a lot of it planted. It would make a steady about $100 an acre a year from then all the way through to the end. And when you look at corn and beans, they were break even many years and below break even, especially corn, the majority of those years from 2014 on through 2018, 2019. So I looked at Miscanthus, as long as I can still sell it and above break even, and it was more weather tolerant than corn and beans. I was content to treat it as my third crop. When the other two weren't making money, Miscanthus was a steady crop. Okay, next slide. My market, like Steve said, is poultry. At first I grew for ethanol, but it was soon discovered that making ethanol from biomass was a tricky thing. It was expensive and a lot of problems involved with it. And as the price of ethanol dropped from $4 to $1.98, $2 a gallon, the shine of ethanol went away and people lost interest in it, really. There wasn't much interest in doing much research on it, at least not for automobiles. So, and not only that, electric cars come along. It seemed like the future for ethanol wasn't nearly as bright as what it first was. And so I went looking for other markets. And I'd heard about the eastern markets with markets for poultry. And Illinois actually has quite a few turkeys growing within 40 miles of where I am. And we found a grower who was interested in trying it. He loved it and took all I had for a few years. Then he retired, but he passed it on to a young guy starting, and I can take him all I've got. And there's another guy wanted to try it, and I know there's a bigger market down there. In fact, the guy I'm selling to would like to plant 100 acres of Miscanthus just to have enough for himself and be able to sell a little bit to his neighbors. So there's a huge market in poultry, but I think in the end, the larger market is going to be still in energy. The efficiencies are just too great. To ignore that market, and I look at energy not necessarily so much as liquid fuels, but as gas, LP gas. That's our heating market. You can heat the raw material to get the same amount of heat as you can from LP. You can get it for $90 a ton. Will heat just as much as $300 worth of LP. Those prices are, that's what I filled my tank for here last week. So I know they're legitimate. The only problem is to heat it, you need a special boiler that can burn biomass very cheaply. But those opportunities are out there, I think. My turkey grower, I walked out behind his building one day and he's got two 12,000 gallon LP tanks. It takes a lot of heat to heat those birdhouses, and if I had the material to sell him, I'd try harder to convince him he needs to be putting in a boiler that can burn biomass and use what I send for heat rather than scatter on the floor for bedding, or even do both. You can burn, maybe you ought to be burning his bedding too. A lot of opportunities there. Anyway,
Yeah, we've gotten some questions that come in. So
there's my story right there. Okay, go ahead.
excellent. All right. So one of the questions that came in, I'm going to direct towards Emily. When was Miscanthus introduced to the U.S. and are there any concerns of it becoming invasive?
That's a great question. Miscanthus was introduced to the U.S. as far as we know sometime maybe in the 50s, maybe in the 70s. It came into the USDA germplasm system in Miami, actually, and it was brought into Europe in the 30s. So it's been tested for its invasive potential in Europe since the 1930s. I have a fact sheet about this in the extension store, and I can put the link in the chat. But suffice to say that of all the new crops that have been tested in what is considered the most rigorous weed assessment framework in the world, which is the Australian Weed Risk Assessment Framework, Miscanthus comes back consistently non-invasive. And this type of Miscanthus is very slow to spread in general, and it does not make seed. So my mom told me a long time ago to be careful about being famous versus infamous. And so I chose to work on a non-invasive crop because, we don't need any more kudzus or multiflora rose. So that's a great question.
And speaking of different maybe varieties of Miscanthus, are there any clones or varieties that are better for overwintering? Or is that still a frame of study?
Oh, that's a great question, and one that Steve is helping us figure out. There are types of Miscanthus that are better at overwintering. Miscanthus is actually, this type of Miscanthus is from all the way up by Siberia, actually, the Amur River Valley in Russia. So it's very, very stress tolerant, particularly with cold. But some of those types that have that cold tolerance have not been fully tested for productivity or for invasive potential. So we have a breeding program in place. There's one based at the University of Illinois. And then there's another really big one in Europe, in Wales, where we test those questions. So yes, there are new varieties that are in development that will be more cold tolerant as well as have other desirable traits.
So is Miscanthus appropriate? You showed that picture for land that's frequently flooded, such as beside a river or creek.
The short answer is probably. If that area beside a river or creek is going to be frequently disturbed, like if you're going to get gully washers that really are going to wash things away, you do want to be careful about the movement of rhizomes. Steve and I learned this the hard way at his field one year. He had some slight movement of rhizome pieces. They didn't, they don't spread quickly, so they don't become problematic, but it can move. That said, Miscanthus rhizomes form almost a rebar type interlocking structure. Just like rebar reinforces concrete, those rhizomes do the same thing for the soil. So if you're not in a place where you're concerned about some slight movement of the rhizomes, yeah, I think it's a really powerful tool to stabilize stream banks. We're still trying to figure out how much flooding it can tolerate. We actually have a body of research right now looking at Miscanthus in potholes. The Miscanthus stem acts like a straw, letting the crop breathe. And Liz is part of this project too, if you want to find more about the profitability of Miscanthus and potholes later. But the stem can allow the plant to breathe. But even cattails can get drowned out if they're too young, if that stem hasn't come above the ground and created that snorkel yet for the plant. So that's an active area of research.
So this is a question for Eric, and I'm re-showing the slide because they're related to this particular chart here. So there was a question of like, what happens when you take out the subsidies? I did the quick math. Corn would have been 194, soybeans 234 compared to the 129. But someone also asked, and notice that your land rent for the Miscanthus was 220 versus your corn and soybeans. So they're curious what your yield potential of corn and soybeans would be on that land. or is that already discounted because it's in Miscanthus?
The land is definitely poorer. I don't, and I have a landlady who was interested in this as I was, and because of the upfront cost to establish the Miscanthus, and because the real uncertainty of if it was going to pay or not, she gave me that land for a lower rent, and she continues to do that today. So, and it's a fair rent because I'm not making as much as corn and beans in the long run, and I'm still experimenting. So I got a little break from the landlord on that. The land is poorer to begin with, and there's more risk involved and less yield. So those are the reasons.
So this one I'll direct to Steve and or Eric, whoever wants to take this one, but what do you need for storage space for the harvested Miscanthus before it's moved to market, and how is that handled?
A lot. I figured out it's about 5 times what it takes for corn, more in volume anyway. It takes a lot, and that's a definite concern. We used to have old flat storage at the local elevator, and he would allow us to use that storage from February through September, to the August, the end of August, 1st September, when he had to use that storage again for beans. So we had that for a pretty cheap rent then, but we had to move it out by fall, before fall, get it cleaned out. They since tore that storage down, so now I'm using silage bags, more expensive, but yet I've got more independence in what I can do with it. And there's a lot of advantages to silage bags, really, but overall they're still expensive. I don't know what you're doing, Steve, or what I was doing.
Sorry, Steve, I'll unmute you.
We are using silo bags until it can be moved to the consumer. Evergreen Nursery up in Marion, who takes the product right out of the chop. First of all, I should say it's harvested through an insulage chopper process. So the same mechanism that you use to fill silo bags with insulage works with Miscanthus. And we're able to, a lot of my product goes up to, like I say, Marion, Iowa, and the silo bags are filled up there so that he has it on site that he can then use and move into making the tube socks with the chop. The other form of harvest is in round bales. We use a flail chopper. The insulage chopper takes it down to something below 18 inches. We're going to try a new head this year, which may take it down even lower than that. But we then flail chop that stalk that's left, and then have been baling the litter and that material into round bales. They weigh about 1,200 pounds. Those we do edge of field storage, or I take them into the farm and I've got old feeding stores that used to be cattle that I store.
So a couple more harvest related questions have come in. One, do you lose any value by harvesting later, like March or April? And what's the moisture content that you're aiming for when you're chopping and harvesting it?
Well, that's the key. Our consumers want, the people who, like University of Iowa, wants moisture below 18%, and really prefers below, or 15%, which is about as low as you can get moisture of a crop. So Miscanthus tends, Emily can say why this is the case, but it tends to retain moisture over the winter. And so it's just, we keep testing it, and it's not until March or so that we can get the the moisture below that 18% in order to harvest it. So we don't lose any tons, except in the weight and water moisture, but because the product stands well, it withstands snow, wind. We get some lodging that comes if we have an ice storm and with a real wet snow, but not very much. And so I don't see that we lose anything by late harvest.
I know there's a couple more.
To go along with that, Steve, we've had one field we didn't harvest one year, and we went back and harvested then a full year later, and it stood just as really good. I mean, we didn't lose any to lodging. You lost a little to those stems out there, blocked a lot of light, and so the second crop only was 2/3 of the crop. So we ended up harvesting and a crop and 2/3 in 1 year. And I think we came out even there because we only ran the chopper over 2 crops one time, and we were probably money the same. So it's a unique crop in that sense.
And I know I've got a few more questions, but I want to just make sure I get these last couple things shared. One is that if you attended for today's CCA credits, please email me. My email is there by 5 p.m. today with the name that you entered to watch the virtual field day and your CCA number, and I'll get that submitted so you get your credits. And a week from today, we have another virtual field day, this one on oxbows. So we hope you can join us then. And again, if you have a few more questions, we'll try to get those answered. If not, I will direct them to Emily, Steve, and Eric and help connect you to get them answered after the program as well. So now Emily's answered a few questions in the chat regarding wildlife habitat and sequestering carbon. So feel free to check those out if you haven't already. This one also for Emily, is there a pellet market, fuel market developing anywhere?
Not right now. It comes and goes. Essentially what the University of Iowa is doing is making a pellet fuel to replace coal, but there's more to unpack there.
So kind of back towards the harvest side, would it be economical to bale the chopped material into big square bales for storage and handling purposes? It was mentioned round bales, siling bags. What about large square bales?
Large squares are fine. That's what the people in Oklahoma are doing is large squares. They transport better, and they're transporting them into Tennessee. That's their market. In our case, I'm trying to do it with existing equipment, and round bales are not what we do in my part of Iowa. We just no one does large squares, and we use round bales for corn stalks and hay and everything else. So we're using existing equipment. That's how we keep the cost in mind. And also, I should say, the large round bales are used by the blowing on as mulch by the people who have construction sites. So their equipment too is made for the large round bales to put it through a grinder and blow it. So right now it's the best for my market.
All right. So
yeah, just a comment here, if I may. Be careful when you reprocess. Every time you handle it, it costs a lot of money. That's why chopping is so efficient. If you one pass and you're ready to go. You're ready to burn it, ready to use it, wherever. And so you can, to pelletize it, it can be pelletized, but it doubles the cost of the biomass right there and adds another $70 a ton. So it's not conducive, and you don't gain that much baling or chopping. You gain about as much as about 2/3 of what you can baling. I don't want to put that. In other words, a cubic yard weighs what a 1.7 cubic yard weighs when you bale it. So chopping really densifies it in a way. If you chop it small, it densifies it. If you understand me, I'm not being very clear here, but I do know that push the numbers before you run, before you do much baling or compacting or pelletizing.
Eric and I, of course, have a different view. Mine is that it all depends on your market.
Yeah, well,
Consumer
yeah,
is
yeah.
king.
That's
Consumer is king. So it's you put it in the product form that your consumer needs it.
Yep.
So
right, Steve. Yeah, I just pointed out.
All right, so I put the CCA information in the chat if you missed it earlier. I've got one last question before we sign off today, and I'm going to direct this one to Emily. Does a late harvest versus an early harvest affect the nitrogen that would be needed in the future in terms of the nutrient movement back to the rhizome?
That's a great question. And actually some of the people on this call are analyzing that question right now. We think so, but we don't know how much it matters. So that's an active area of research. What I will say is that we have done a lot of different nitrogen testing, and we found that a little bit of nitrogen goes a long way, no matter how it was harvested. We don't see a benefit of nitrogen fertilizer over 100 pounds per acre. We expect the nitrogen needs are somewhere between 30 and 80 pounds per acre based on what we've seen. And I think we can improve that through management. So Marshall McDaniel, several others that are part of Iowa Learning Farm events are actively researching some of this, and we're modeling it with ecosystem models as well.
All right, that's what I have. I have had a few requests from attendees wanting contact information from our speakers today. So if you want to stick around just a little bit after this, I can follow up with those folks that have requested contact information. But otherwise, that is all we have for today. Thank you so much for joining us. Again, tune in next week as we learn more about oxbows, and we'll see you all again soon. Thanks.
Thanks, everyone.